Hello, everyone. This is Kaizen Base. Today we learn about examples of automation with human touch.
Last time, we had an additional lecture about the idea of the automation with human touch. This time, we show some examples of the automation with human touch.
So, let's get started with today's lecture.
Mio, you taught the automation with human touch. Do you know any examples of structures that use the function to stop in an abnormal?
Yes. I know one of them. The idea is used by the tool breakage abnormality detection of a processor in an unmanned operation line. In the machining process, a machine checks the condition of a tool every cycle automatically. If it detects something abnormal, such as tool breakage, it will stop.
Yes, you're right. The tool breakage detection is a popular example in the automation with human touch. In equipment of a machining process, if a workpiece that is expected to be shaved is not shaved, it will become a defect, or when making a workpiece move, the tool will interfere with it, and a machine will break down. As that will not happen, a machine is incorporated the structure to stop soon after a tool breakage.
I have thought that tool breakage detection was an easy example to understand.
Do you know any other examples?
Let me guess. I'm not sure that this is an example of the automation with human touch, but I think a signal cord may correspond to the idea. It is an abnormality detection, such as delay, in an assembly line of an automobile. An operator pulls the signal cord to stop the line at a fixed position in the assembly line. It is used to stop when something abnormal with a machine or jigs and tools occurs, and the operation is delayed.
Yes, that's right. A signal cord is also an example of the automation with human touch. When a signal cord is pulled, a supervisor will notice something abnormal is happening in a line and can deal with the problem rapidly. The concept of stopping in an abnormal state is applied to not only a machine but also a manual process. Do you know any other examples?
I don't remember. Would you give me a hint?
Okay. Guess what structure to stop stuff sent mistakenly?
Oh, I know. That's error proofing?
Exactly. Error proofing is also one of the examples in the automation with human touch. Error proofing is to put the structure to let an operator physically notice that he made a mistake in equipment or goods. There are many kinds of error proofing devices. Let's check typical ones. First of all, this is the error proofing to prevent the wrong attachment. Its design is made in vertically different shapes intentionally. In an abnormal state, the parts cannot be installed into a jig. Then the operator will notice the mistake soon. Noticing soon when making a mistake is the same idea to stop quickly after seeing an abnormal. There is the design of the parts made in asymmetry shapes in the error-proofing concept. The installed parts are asymmetry. It is a structure not to be installed if trying to put the one in a reverse position. And, showing like this, there is an error-proofing idea that something sent by mistake hit and cannot go through a conveyor line. That is called the shape error-proofing. It is a method to use characteristics of materials, parts, or tools, such as a hole, a corner, or a protrusion, and to distinguish an abnormal between differences.
In addition, I can give the weight error proofing as an example. By setting an upper limit and a lower limit of weight, the out-of-the-range goods are eliminated as defects. Other than we mentioned here, there are many error proofing. The important thing is the structure that an operator can notice an abnormal at once. That's the very idea of the automation with human touch.
Do you know one more typical example in the automation with human touch? The hint is a lamp. That is something flashing.
I know that. That's an on.
Exactly. Well done. The end-on is a management tool to see with eyes, which lets those who need information know the required information conveniently. Its role is to tell site supervisors that an abnormal happens or a measure or dealing is needed soon. In the automation with human touch, it is insufficient to detect an abnormal. The idea should be to send detected information to those who need it. And the tool for that is the end-on.
I see. Not only detecting an abnormal but also sending information to those who need it lead to necessary action, such as stopping or taking measures. In view of the structure to know at a glance, there might be many examples of the automation with human touch in factories. In the 5S activity, we draw white lines around a shift for hand carts and judge as abnormal when the hand cart is sticking out there. This case follows the idea of the automation with human touch in a sense.
Yes, exactly. The idea is required not only in factories but also in every work. Remember, it is important to consider many kinds of the automation with human touch by the structure to know at a glance in abnormal is a keyword.
I see. I will remember that certainly. Now, we make a summary of today's lecture. As examples of the automation with human touch, the tool breakage detection, the signal cord, the error proofing, and the end-on are given. In the automation with human touch, not only detecting an abnormal but also reaching those who need and taking action are meaningful. And, it is important not only to apply the idea of the automation with human touch to a machine but also to consider in view of the structure to know an abnormal at a glance. Not only in factories but also in every work, it is essential to proceed with Kaizen in this view.
Well, that is all about this lecture series. From 1 to 10, we have learned the basic ideas mainly as an introduction to the Toyota production system. Have you understood the overview? That is not difficult. And the idea catches the essence of Kaizen sufficiently.
The introduction lecture is over. But we have many topics that we should learn about, such as the basic, the step up. Aiming to become a Kaizen master, let's continue to learn about Kaizen together. That's all about today's lecture. So, see you at the next theme.